Good evening, everyone, and this is, as you can see, lecture number 8 in today's class, and we are dealing with curved mirrors. We were dealing in the last class, and we were looking at the mirror formula. Yes or no? Do we remember this? We were dealing with mirror formula, and we had seen the important results. I'll just go back. F is equal to R by 2. That is the first thing that we had seen, and 1 by U plus 1 by V is 2 by R, or I can call it 1 by U plus 1 by V is equal to 1 by F. This is the mirror formula. We all remember this, yes or no? We all remember this? We had also seen that what will happen in case of real objects and real image. For a real object, U is going to be negative. For a real object, U is going to be a negative. For erect object, the height of the object will be positive. For a real image, V will be negative. Do you remember this? Okay, then as I said, there is a table that you must remember and understand, and these are the different positions of object and where is the image formed. We will go through these points one by one, and we'll start with the first point. I told you to go through this table, yes or no? I told you to go through this table, yes or no? Have you gone through this? Have you gone through the table? I asked you to go through this table to understand the different position of object and where will the image be formed. Have you seen this? Did you go through this table?
Yes, sir.
Okay. There are 6 locations that we'll have to see for a concave mirror. And the first location is when the object is at infinity. When the object is at infinity, what will happen to the image? Where will the image be formed? The image will be formed at the focus of the mirror. This is how we have defined the definition of focus. Parallel rays. Now, whenever we say parallel rays, that means that ray are coming from an object which is very far away. In fact, it becomes object at infinity. So object at infinity basically means that the rays are going to be parallel to principal axis. Do we understand this? When the object is at infinity, very far away, the rays are going to be parallel to the principal axis, and hence the image will be formed at the focus. We all understand this, yes or no? Can I have some raised hands from everyone in the class? We understand this? Now, you'll have to remember all these things. The magnification is the next point. Did we talk about magnification? We have not talked about magnification. So what we will do is, before understanding this table, we will first understand the meaning of magnification, and then we will come back. We will come back to this table to write the next heading, and the next heading is magnification. So let us first go through this magnification, and then we will turn back and discuss the different position of the object and the different position of the image that will be formed. Magnification. Have you heard this term magnification? Anyone? We have discussed, I had talked about magnification in plane mirrors. I told you that the magnification in case of plane mirrors is 1. What do you mean by magnification? Now, whenever we talk about magnification, There are two types of magnification that are going to come and we will have to discuss them. The meaning of the term magnification remains same, but they might look somewhat different when we talk about how do we talk about them. So the first type of magnification is known as transverse or lateral magnification. Transverse or lateral magnification. And the second type of magnification is known as longitudinal magnification. So there are two types of magnification that we are going to deal with: transverse or lateral magnification and longitudinal magnification. They actually mean the same thing, but they might look somewhat different. So first we will write transverse magnification, which is also known as lateral magnification. Any idea what this transverse magnification would be? Anyone has any idea about this transverse magnification? Have you heard this term, transverse magnification? Oh. Asking about transverse magnification, have you heard the term magnification? What do you understand by the term magnification? You may not have heard transverse magnification, but have you heard the term magnification, beta? Yes or no? No or yes? Have you heard the term magnification? No one is saying anything? Am I audible and visible to all of you? Have you heard the term magnification, beta? You don't have a mic that is working?
We do have mic, sir.
Okay. So you don't know what is magnification. So you say, sir, we have no idea. Not a problem. If you don't
No idea, sir.
Okay, not a problem. No idea is not a bad thing. No idea is a good thing. Having half of the idea may be a bad thing. Now, transverse magnification is what we are talking about, and this is a diagram that is going to illustrate the concept that we are going to understand. Let us first try to understand the different terms that are coming here. What is this entire thing? We are an object, right? So AB is your object. Is it an erect object or is it an inverted object? Let us first discuss this. Is this an erect object? Yes or no?
Yes,
This
sir.
object is erect.
Yes, sir.
So that is the first thing that we have seen. This object is erect. Now let us talk about the second thing, and the second thing is what I have highlighted in yellow. What is this yellow thing? Let us first discuss each and every point so that we are conversant with that terminology. What is this yellow thing that I have highlighted? Is there on the board, beta? I hope you can see it. I hope the diagram is big enough for you to see. What is this yellow thing that I've highlighted? What is this? You can't read it?
Distance of the
Object
image.
distance, sir.
Yes, this is you. If I might say, this is you, and this is nothing but the distance of the object from the pole P of the mirror. We had seen sign convention in the last class, yes or no?
Yes, sir.
All distances are measured from the pole P of the mirror. Distances measured in the direction of light are taken as positive, and distances measured opposite to the direction of light are taken as negative. Here u is always known as the object distance. Now can you tell me, using the sign convention, whether this u is going to be positive or negative? Remember, all the formulae that we have seen will be applied with sign convention. So my dear friends, tell me, is this u positive or negative?
Negative, sir.
Negative, sir. What type of object is this? Is this a real object or is this a virtual object?
Real object.
Real
Yeah.
object.
So now we have understood this term that this is a real object, this is an erect object, and U is going to be negative for this object. Let us see the next point, which is HO. Can you see this HO in green?
Yes, sir.
Yes,
HO.
sir.
What does HO mean? O is here.
Height
Height
of
of the
the
object.
object.
HO means height of the object. H standing for height. Let me write it bigger. Oops, wrong color. I'm very particular about colors. Let me write it in a bigger thing. H means height. O means object. Second term, we have understood the second term. Now let us talk about this thing. What is this A dash B dash that you see?
Image.
That is the image. Correct. Now can you tell me, is this a real image or is this a virtual image? Is this a real image or is this a virtual image?
Real image, sir.
Real image. Why it is a real image? Why is this a real image? What makes you think that it is a real image? Yes, bacha, tell me. Why is this a real image? Have you drawn the diagram, beta? You have to draw this diagram. You have drawn this diagram, yes or no? I'm explaining the diagram. Meanwhile, you will draw it. Are you drawing the diagram, yes or no? Please raise
Yes,
your hand.
sir.
Okay. Why is this a real image? You know it or you don't know it?
Point of intersection of reflected rays will actually meeting.
Yes, they are actually meeting. As you can see, my dear friends, this is my first ray, incident ray. This is my reflected ray going like this. One ray here. Then I've taken the second ray. The second ray goes like this and it gets reflected like this. And as you can see, both of these rays are meeting. They are actually meeting, and therefore it is a real image. Do we understand this? It is a point of intersection of reflected rays. If they actually meet, it's a real image. If they do not actually meet, they appear to meet, then it is a virtual image. Am I clear? Are the concepts getting clear? Yes or no?
Yes, sir.
Okay. Now tell me, is this a inverted image or is this a erect image?
Inverted image.
Inverted.
Inverted image. So always remember, my dear friends, whenever we have a real image of a real object, the image is always going to be inverted. Now, here I have forgotten one thing. We are talking about sign convention. What will be the sign of HO? Will it be positive or will it be negative?
Positive.
Positive.
Positive. Well done. What will be the sign of HI? I did not write HI. This is that blue thing, HI. HI means height of the image. HI. HI means height of the image. Now, can you tell me, this pink gentleman, this height of the image, will it be positive or will it be negative?
Negative, sir.
Why, sir?
It is below the principal axis.
It is below the principal axis, so HI is negative. That is correct. I also see one more thing which is in blue. Can you tell me what is this? The blue thing?
Image
Distance
distance from the
between.
pole.
Well done. This is the distance of the image from the pole. Also tell me, is it positive or negative here?
Negative.
Negative, sir.
It is negative here. So is the sign convention clear to all of you? Yes or no?
Yes, sir.
What type of mirror is this?
Cave.
Concave
It is
mirror, sir.
concave mirror, and as you can see, I can write its focal length. Its focal length is distance from here to here. Can you now tell me whether its focal length is positive or negative, my dear friends? This focal length is negative. Do we understand this? Yes or no?
Yes, sir.
Okay. Well, so this one diagram has made us understand everything that we should know. Have you all marked this thing, everything? Yes or no? Have you marked this, everything?
Yes, sir.
Can I rub them off so that the diagram looks a lot better?
Yes, sir.
Okay, so what I'll do is I'll rub everything off so that once I have made you understand everything, there is no point of keeping them, and let me have a clean slate. So now I have a clean slate. Everyone has noted this down?
Yes, sir.
So now I have a clean slate like this. Now, we were talking about transverse magnification. Transverse magnification is denoted by this letter M. Small m stands for magnification. Now, physics में the meaning of every term is hidden in the term itself. So, my dear friends, what would magnification mean? Here, we only have four things that you can see. One is U, one is V, one is HO, one is HI, and the other one may be the focal length. There are only five things here. How will I define magnification? Can anyone tell me? Guess.
Height of the image divided by height of the object.
That is absolutely correct. This is height of the image I divided by height of the object O. So I can simply write it as HI divided by HO. Do we understand this? Yes or no? No or yes?
Yes, sir.
This is as simple as this. This is known as the transverse magnification, height of the image divided by height of the object. Now, I can write the same thing in terms of U and V. Now, how will I write the same thing in terms of U and V? Let me again take things off so that the diagram looks better. Now, I'm going to mark two angles. This angle and this angle. Two angles are marked in red. Are the two angles equal?
They are equal, sir.
Why they are equal, sir? One is the angle of incidence
Incident
and
reflection.
other is the angle of reflection. Now, my dear friends, you can look at this green triangle which I have drawn and this blue triangle. And I know you are biology students, so you may not know what is similar triangle. But this green triangle and this blue triangle, because of the angle, they are similar. Yes or no?
Yes, sir.
Since they are similar triangles, I can write HI divided by HO, height of the image divided by the height of the object will be equal to V by U. Yes or no? No or yes?
Yes,
Yes,
sir.
sir.
But here, if I talk about sign convention, because HI and HO, one is positive, other one is negative. So HI by HO is negative. But if I talk about U and V, both are negative. So negative by negative becomes positive. So make them correct. I will have to write it like this. So now I have one more formula for magnification, and the formula can now be written as HI by HO, which is equal to minus of V by U. This minus sign comes because of the sign convention. Do we understand this?
Yes, sir.
So these are the first formula, the formula which is in the yellow box. This is the actual formula, but I can write it in terms of the green box also because both are similar. Do we understand this, beta?
Yes, sir.
Blue box and the green box, they are both similar. This is known as the magnification of the image or the transverse magnification. Now remember, we also have the mirror formula 1 by u plus 1 by v is equal to 1 by f. Here, my dear friends, what I have done or what we have done is written the magnification in terms of v and u. I can also write this magnification in terms of f and u. I can also write this magnification in terms of v and f, and hence we can have four different formulae for the same thing, but trust me, they all mean the same thing. So now I will write them all the four formulae together. The more you can recollect, the better it will be for you. So these are the two formulas that we have already discussed. From the mirror formula 1 by u plus 1 by v is equal to 1 by f, I can find out the value of v by u, and I can write this formula like this: f upon f minus u. I can also write it as v upon f. Oh, I have written it wrongly. I make a mistake. So I can write it as f minus u by f, or I can write it as f minus v divided by f. Now, if we can remember these formulae, it is going to serve a lot of purpose. Here in this blue box, all the formulae for magnification are written. If you can remember any one of these, you can find out the other ones. But if you can remember all of them, it will help you in saving a lot of time in the examination hall. Magnification, lateral magnification is hi by ho minus v by u, f upon f minus u, or f minus v divided by f. Remember, all these formulae must be used with proper what? They must be used with proper
Sign convention.
sign convention. So I will have to apply sign convention and then only use this formula. Without sign convention, these formulas are not valid. Anyone has any doubt, please raise it now. Anyone has doubt, please raise it now. I'll give you a minute to note it down. Have you noted it down, my dear friends? Can I move ahead?
Yes, sir.
Now, important things that you must remember about this magnification. Point number one, for real image, now I will not tell you for real image, and let me take you to the slide. For real image, think whether m would be positive or m would be negative. Real image. Real image.
Negative, sir.
Why, sir?
Height of the
Because
object will be positive, height of the image will be negative.
Well done. That is the thing that you must understand. If the object is erect, like this, in the diagram it was like this. If the object is erect, image would be inverted. One would be positive and the other one would be negative. So for real image would be inverted. m is negative, or I can say m is less than 0. Do we understand this? Yes or no? No or yes?
Yes, sir.
If you can remember these small things, beta, you are going to score very heavily in the examination hall. Since I have written it for real image, now you can tell me what will happen if the image becomes virtual. For the virtual image, yes, my dear friends,
Magnification is positive.
magnification is positive. That means the virtual image would be erect, or I can say m would be greater than 0. We are writing the important points. We are dealing with transverse magnification, and we are writing the important points. I hope all of us are together. Can I have raised hands from everyone that we are together when we are noting down? Boys in the class, are we there? Okay. Point number 3. Now, sometimes you may have magnification as -2. Now, if the magnitude of magnification, here we are talking about magnitude. So if the magnification is -2, the magnitude becomes +2. If the magnitude of magnification is greater than 1, this will imply that the image is enlarged. That means it is bigger than the object. Do we understand this? Yes or no? Plus or minus only indicates whether the image is real or virtual. The number tells us whether it is bigger than the object or smaller than the object. If the number is bigger than 1, magnitude is bigger than 1, then the image is enlarged. Do we understand this? Can I have raised hands from everyone? That yes, sir, we understand this. Then there will be a fourth point which I will not write, which I would ask some of you to tell me what would be the fourth point here. Who is going to tell me what will be the fourth point? No one?
If magnitude is less than 1, image is diminished.
Not magnitude, my dear friend. Please correct it.
Magnification.
If the magnitude of magnification, my dear friend, bacha, if the magnitude
Okay,
of
sir.
magnification is less than 1, then my image is diminished. When I say diminished, it means it will be smaller in size as compared to your object. As compared to the object, the image would be smaller. The height of the image would be less than the height of the object. You can also write it like this. Height of the image would be less than the height of the object. If you want to understand it in a better way, here you can write height of the image is greater than height of the object. If anyone has any problems, any doubt, please raise it now. I hope everyone has noted this down. Yes or no? No, yes.
Yes, sir.
Shall we move on to the next point?
Yes, sir.
What would be your next point? Tell me what is the next heading? We are done with lateral magnification or transverse magnification. What would be my next heading?
Longitudinal
Hey,
magnification.
longitudinal magnification. Now, since you understand what is lateral or transverse, can you guess? Nice little guess, small little guess. What would be a longitudinal The meaning is hidden in the word itself. What would be longitudinal magnification? Longitudinal, along the axis is longitudinal, and my dear friends, this is the diagram that will illustrate us what is longitudinal magnification. And I won't say anything. Can anyone tell me what is longitudinal magnification? Looking at the diagram and understand what is the difference between this diagram and the previous one. Yes.
Object is placed longitudinally.
What
In
do you
the
mean by longitudinally? It is, see, in first case, it was transverse. Transverse means perpendicular. Transverse means perpendicular. So in that case, the object was placed perpendicular to the principal axis. Do we understand this?
Yes, sir.
This was the object. This was my principal axis, and the object was placed perpendicularly. Here, the object is placed along the axis, along the principal axis. That is the first difference. So, the object is placed along the length or the principal axis. So, first point you have to remember, if the object is placed, and we might have a question on this if they give you a tough question in NEET, then this question will come. Otherwise, the question will be from transverse magnification. If the object is placed along the principal axis, then the magnification is known as longitudinal magnification. But how will I define it? Longitudinal magnification is denoted by the letter M with L. L standing for longitudinal. So for that matter, you can say transverse magnification as MT, but we simply call it as M. Now. Can you tell me how will I find it from here? So you have an object placed along the axis, and obviously you are going to get this image. How will I get the longitudinal magnification? How will I define it? Anyone? Yes. There it was, height of the object divided by the height of the image divided by the height of the object. What would be the case here, my dear friends? Yes, I'm waiting. No one? No one?
Distance of the image and distance of the object.
Distance of the image does not make sense. Which distance you will take? U1, U2, V1, V2. Distance of the image. Height of the image, height of the object. Here what? Okay. You can call it length of the image. Image has a length now. Length of the image divided by the length of the object. And if I may just write here, this as Li, Lo, and this gentleman as Li. My answer will be Li divided by Lo. Do we understand this? Yes or no? No or yes?
Yes, sir.
So then you can simplify it by V2 minus V1 or V1 minus V2 divided by U2 minus U1 depending on which is bigger. You can just take the magnitude of this thing and you will get the longitudinal magnification. Is it difficult for you to understand this? You might not get a question or ever on this, Because to get the answer for this, how will you have to solve the question? First of all, you have to take this point as u1, and then you will have to find out the value of v1. Then you will have to take this point u2 and then find the value of v2. Then subtract v2 or v1, v2 minus v1. Then subtract u1 minus u2 or u2 minus v1, and then you get the value. Do you understand this? Yes or no? No or yes?
Yes, sir.
Yes, sir.
I hope I am not making it difficult. You may not get this, but this is my duty, humble duty to tell you this, because if this question comes, I must not repent myself why I did not tell the kids. It will not come. Now, here there is one more important point that you have to remember. Only the formula. If the object is very small, and again, you will only get a question of this nature when the paper of NEET becomes very tough. If the object is very small, chota, 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 then the longitudinal magnification is defined as minus dv by du. dv means small length of image, du means small length of object. So what we have done here is v2 minus v1 has been replaced by dv, and u2 minus u1 has been replaced by du. Do you understand this? Yes or no? No or yes?
Yes, sir.
Well done, sir. Very well done, sir. So I guess that you are going to note it down. Yes or no? No or yes?
Yes, sir.
Please note it down.
Done, sir.
Done, sir. Well done, sir. Again, there is a small formula here as well, and you will have to remember this. Again, there is no point of understanding how this formula has come. So I have lateral magnification as, for a small object, I have it as minus dv by du, and it can be proved easily that this will be equal to v by u ka whole square, neglecting the negative sign. So your lateral magnification can be written as this formula also. And therefore, I have a third formula where I can relate longitudinal magnification with lateral magnification. And you remember this like this: ml is equal to minus dv by du. If you have to find out from derivative, that will be equal to v by u ka whole squared, and that will be equal to your original lateral magnification ka square, because lateral magnification is v by u. So v by u ka square is m plus square. Negative sign doesn't matter. Do we understand this? Yes or no? No or yes?
Yes, sir.
Yes, sir.
Well done, my dear friends. If you have understood this, we have taken one giant step in the history of mankind. This is one giant step in the history of mankind. One giant step in the history of mankind. I hope everyone is noting it down. Yes or no? No or yes?
Done, sir.
Done, sir. Well done, sir. Then again, I'll give you one more added information. Again, this might never be required. It's my humble duty to do it. The third heading is known as superficial. superficial or aerial magnification in area. Superficial or aerial area magnification. Area magnification, you will say, sir, what you are talking, sir? How will the area magnified? It's not good. How can you magnify area? What do you mean by area magnification, sir? We don't get it, sir. Please make us understand with a diagram, sir, and I will show you a neat and clean diagram for this. I'll show you a neat and clean diagram for this, and probably then it will start to make sense. Now, when this aerial magnification or superficial magnification is going to come, it is going to come, my dear friends, when instead of a linear object like this, you have an aerial object like this. This gentleman has a height. It also has a width. Are you getting my point, bacha? So you have a sheet of length as well as breadth, or height as well as breadth, whatever you call it. Now, if you put this thing in front of a mirror, you will get image which will be two-dimensional in area. Yes or no? No or yes? Are say?
Sir, can you repeat?
If you have a two-dimensional object like a sheet of paper, like my hand, now this camera is also creating an image of the hand. Are they of the same size? No, na? My height, my palm might be more wider and having more area than the image of the palm that you are seeing. Yes or no? That is aerial magnification. Magnification in area. Do we understand this?
Yes, sir.
Small thing looks bigger. Aerial magnification. So instead of a line, you have an area, and the area gets magnified. That is known as superficial or aerial magnification. It is denoted by MS or MA. So how will I define this? Lateral magnification was height of the image divided by height of the object. Longitudinal magnification was length of the image divided by length of the object. What will be aerial or superficial magnification equal to? Tell me, yes or no, no or yes?
Yes, sir.
What? What will be the definition? That's what I'm asking. You're asking me the same question again. It will be? Everything is written here.
Area of the image by area of the object.
Yes, it will be area of the image divided by area of the object. If you understand simple things in life, life is going to treat you like a princess and prince. As you can see here, yellow width is W naught, WO. The image ka width becomes M times WO. It gets magnified M times, where M is your lateral magnification, my dear friends. Similarly, HO is the height of the object, and HI is the height of the image, and it will become magnified M times. Are you getting my point, bacha?
Yes, sir.
Then, sir, the formula becomes very simple, sir. It is M times HO multiplied by M times WO divided by HO into WO. This goes away, this goes away, this goes away, this goes away. And my superficial expansion becomes M squared, where M is my lateral magnification. Are we getting this? Yes or no? No or yes?
Yes, sir.
Yes, sir.
And I hope, apart from getting it, we are also noting down this. These are all gold dust, my dear friends. Very valuable. Gold dust. Pure gold dust. The more you note, because whatever question comes, my dear friends, it would be a straightforward one from here. A straightforward one. no chal kapat, no no deception. Straightforward question will come, my dear friends. And that time you will recollect, oh, sir has said this, ki this will come now. It came now. Oops, what has happened here? Something not good. So, I hope everyone is noting it down. Till the time I get this thing to work. It got stuck somewhere. Okay. Have you noted it down, bacha?
Yes, sir.
Yes, sir.
Okay. So now I'm just going to show you everything together in one diagram, and this is everything together in one diagram. Linear magnification was the first thing, or magnification. Linear magnification or magnification is of two types, transverse and longitudinal. And then you have aerial magnification or superficial magnification. Where when the transverse magnification come, when the object is placed perpendicular. Yes or no? No, yes.
Yes, sir.
And this is the formula for this transverse magnification. For aerial or superficial magnification, it becomes when the object is placed along the principal axis and the formula starts to look like this. This was again the formula for small objects. From here, you can find out the length of the image. Length of the image will be v by u ka whole square multiplied by length of the object. Very simple. Everything has been given to you, my dear friends. Magnification in area or aerial magnification is area of the image divided by area of the object. I hope everyone is noting it down. Yes or no? No, yes.
Yes, sir.
So now we understand the meaning of magnification. Now it's my humble duty to take you back to the past. Back to the past where we were discussing where the object was and where is the image going to be formed. Have you noted this down? I've already given you all the formulas. These are just all the formulas put together at one place in one table, if you want to say that way. Are you noting down this table or you are done?
Done, sir.
We have noted everything down, beta. This is just the table that I had given you separately. Now I've just shown it to you in one shot. So
Sir, please wait for 2 minutes. We are noting it down.
okay, okay, okay. I'll wait. See, I've told you everything in separate columns. I wanted to show you everything on one thing, and this was the only way to do it. That's why I've shown you the screenshot there. Everything in one table. If you want to write it this way, well, you are welcome. That would be better because everything is there in one shot. There it was different because I had to explain the entire thing. If you want to write it, be my guest. I'll give you a minute, 2 minutes. Please let me know once you are done.
Done, sir.
The other class, are you done?
Completed, sir.
Completed, sir. That takes me again to the point where we started the class. We may not be able to do this in this class. Don't worry, we will do it in the next class. Concave mirror, where the object is and where the images are going to be formed. Remember, you will get a question directly from here. Directly from here. If the object is at infinity, I've already discussed. If the object is at infinity, the rays would be parallel to principal axis. Do we understand this? Yes or no?
Yes, sir.
Then the image is going to be formed at F. All the rays would be converging to this point in case of a concave mirror. So the image formed would be very small. Do we understand this? The image formed would be very small and therefore we call it diminished. Do we understand the meaning of the term diminished?
Yes, sir.
Yes,
It
sir.
would be very, very small, almost like a point, diminished. The image would be real and the image would be inverted. Anyone has any problems with this?
No, sir.
No, sir.
I hope you are writing it down. Okay. Now, how this positions are achieved. Let me just show you with a small diagram which I can draw. How we are getting all these images, beta? How we are saying? So let us say we have a concave mirror here. Okay. This is the principal axis. So the first point that we are talking about is infinity. That is the first point that we are talking about. Then let us look at the different regions that we have. I have a C. What is C?
Center of curvature.
Well done. I have a F. What is F?
Focus.
Focal point.
Focal point of focus. And I have P. Now I have 6 different positions. The first position is the yellow one. It is infinity. What is the second position? It's from C till infinity. So we call it beyond C. Position number 2 is between infinity and C. Do you understand this? Position number 2.
Yes, sir.
So the
Yes,
first
sir.
position is infinity. Now you are coming towards the mirror. So the next position is between infinity and C. What would be my third position? My third position is when the object is placed where?
On center of
On center of
curvature.
curvature.
At C. That is my third position. Then what is my fourth position?
Between center of curvature and focus.
My fourth position is between center of curvature and focus. What is my fifth position?
On focus.
My fifth position is at the focus, not on, at the focus. Then which is my sixth position?
Between focus and pole.
Between focus and pole, that is my sixth position. So basically how we are going to solve it or how we are going to understand it, this is my mirror. The first position is at infinity. Now slowly we are coming towards the mirror. The second position is between C and infinity. The third position is at C. The fourth position is between C and F. The fifth position is at F. And the sixth position is between F and P. These are the six positions where we have to understand where is the image going to be formed, and you can never forget it. So we will be dealing with these six positions in the next class, and we'll be writing some very important points about these six positions. These six positions are already there on the screen, and you can easily find them in the books that you have, in the study material that you have, in the CBSE textbook. Anywhere you will find these six positions. Yes or no? We have discussed the first of these positions in today's class, which is at infinity. If you can go through the other five positions on your own, that would be better. If not, in any ways, I am going to cover it in the next class. If you can do it, we can do it faster. If you don't do it, we'll go a bit slow. So, on that note, we are going to meet in the next class. What we have done in today's class is that we have understood the concept of magnification. We have understood what is linear magnification. Then linear magnification or magnification can be of two types, longitudinal or lateral. In lateral or transverse magnification, object is placed perpendicular to the axis. In longitudinal magnification, it is parallel to the axis. In aerial magnification, it is an area. We have seen the relation between those quantities. Remember, a straightforward question is going to come from these. If ever the question comes, we will tackle a few questions in the next class once we are understood these positions, and then I will show you what types of problems are asked in the exam, and we will be dealing with those problems. So, if you have any doubt, you can come up. Else, the class is dismissed from my end. Take care. Have a nice day, and may God bless you all. Bye bye.
Thank you, sir.